Welcome to day one of statistics. Since we had some technical problems this morning, I'm re-recording pieces of this lesson. We're ready to talk about the measures of central tendency and then the measures of variation. As you know, we've done them several times before, and in order to understand a set of data that you're analyzing, you have to have both where is the center of the data and how spread is the data. So this first part of this, the measures of central tendency, find the center of the data. And notice I'm putting that in quotes because that isn't necessarily always the true center, but it's the best way to describe it. You've been doing these since elementary school, so this is not going to come as any surprise. We know the three measures of central tendency as our friends mean, median, and mode. I'm sure back in elementary school you probably learned that the mean, the other name for the mean, is to find an average. Well, now that we're getting more sophisticated and I want you to be ready for college statistics, you need to see the symbols that we typically write mean in as if it was a statistical formula. There's also two things you should know about means. There are two kinds of means. We use the symbol X bar if we are talking about the mean of a sample. You're using a sample, we call it X bar. If we're talking about the mean of an entire population, the whole group, we use the Greek letter mu. It looks like a U with a tail on the front. So you have to be careful which one you're using as to whether you're talking about a sample or a population. To calculate a mean, I'm sure you all are going, well, you add up the numbers and divide by how many there are. Well, in stats, the symbol for to add up is our good friend, the Greek letter sigma. Sigma means sum up. We represent our data with the variable x. So this says sum up our data and divide by the number of items. The number of items is always the letter n. So that would be the statistical formula for calculating a mean. Sum them up and divide by the number of items. Something you've done many times before. Median, on the other hand, is known as the middle value in a set of data. It does not have a particular symbol because we don't tend to use median in other calculations. Mean gets used in many other calculations. Median tends to stand on its own. So the key thing, though, when you're finding a median that must happen is you must put the data in order. It has to be in numerical order so that you can find the middle. Now, we are sophisticated enough mathematicians that we don't have to sit there and cross off from each end of the data. Because as you recall, last year I bugged you about, okay, what if you have 250 pieces of data? Where is the median going to fall? You don't want to sit there and cross off 250 until you get to the middle. We discovered that if it's an even number, 250, the median is going to fall straight down the middle. All you need to do is divide by 2, which would be 125. Okay, the median is going to fall between the 125th then and the 126th. It's going to go right down the middle of them. So we would say we have the median is at the 125th and 126th number. You could then count to those numbers and find your median. On the other hand, if I give you an odd number, such as 125 pieces of data, we know if it's odd, when we cross off from each end, eventually there's going to be one left in the middle. So to find it quickly and easily, you're going to once again divide by 2, which is going to turn out to be 62.5. Okay, since it came out 0.5, you're going to round it up, and it's going to fall on exactly the 63rd number. So then you would count your data, you would count to the 63rd number, and there would be your median. Mode, the measure of central tendency which we use the least, is the most frequent value. It is the one that occurs the most often. If you have a set of data and it has 3 sevens in it that are repeated, and that's the only number that's repeated, then of course your mode is 7. So it's the one that's repeated the most. In this instance, if I give you 2, 5, 8, 3, 2, 6, 9, 4, 2, 8, and I say, what's the mode? You would go, well, which one occurs the most? I see 2 3 times, so the mode would be 2. Mode we use very infrequently, but sometimes it's helpful. Now, my big question to you is, which one of these was most thrown off by having outliers, having wild values that were extremely large or extremely small compared to the rest of the data? Well, if you think about it, I'm going to go in reverse order here. Mode, outliers don't bugger the modes. They're not going to be repeated values. The median is the one in the middle. If you have one extra high value or low value, it's only going to shift the median just slightly off the middle. But it's mean, where we're summing up that data. If you have a very large number and you add it to your sum, it's going to throw your mean off. So mean is the most likely to be affected by extreme values. At this point in time, as I'm trying to keep this short, I'm not actually going to run through an example of those, since I'm pretty sure you've done those many, many, many times before. We may come back to that later in another calculation. Okay. However, I do want you to be able to find statistics with your calculator. So we are going to be learning shortly, remembering how we find values with our calculator and how we create different graphs. You'll notice down below here I have some what are called histograms. Histograms are not bar graphs. They look like bar graphs, but they show you how spread your data is. We will be using histograms more, and we will be creating them on calculator, but I want to skip that for right now. I'm going to record this video in different segments so you can watch the segment that you need. So right now, this is the end of set measures of central tendency, and then I'll do something else.